Today we're going to be talking about parallel lines and transversals, and we're basically going to be answering this question today. What happens when two parallel lines are cut by a transversal? Well, here's what happens. I've got a whole list of things here for you. If two parallel lines, which is what we have in the picture, are cut by a transversal, then the corresponding angles are congruent, the alternate interior angles are congruent, the alternate exterior angles are congruent, and the consecutive interior angles are supplementary. So this is a list of things that you're going to want to have in front of you. And again, this is what happens when you've got two parallel lines. So I'm going to say these two lines are parallel. I'm making the notation for parallel here. This is what happens. So, for instance, corresponding angles are congruent in this picture. Corresponding angles are angles 2 and 5. So angle 2 would be congruent to angle 5. Angle 3 would be congruent to angle 6. Those are corresponding angles. Angle 1 would be congruent to angle 8. Angle 4 would be congruent to angle 7. Those are all pairs of corresponding angles. The alternate interior angles would be congruent. Well, alternate interior angles would be angle 3 and angle 8. They would be congruent. And angle 4 would be congruent to angle 5. Alternate exterior angles. Alternate exterior angles in this diagram would be angle 1 and angle 6, which are congruent, and angle 2 and angle 7. And consecutive interior angles would be supplementary. So that would mean that if you were to add angles 3 and 5 together, the measure of angle 3 plus the measure of angle 5 would give you 180 degrees. And similarly, the consecutive interior angles of 4 and 8 would be supplementary. So the measure of angle 4 plus the measure of angle 8 would also give you 180 degrees. Let's move on to our next page. This is just a list of postulates that we're going to be taking a look at. If two parallel lines are cut by a transversal, then the corresponding angles are congruent. That's called the corresponding angles postulate. The alternate interior angles postulate states if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. So this just basically gives us names of the postulates that we just used on the previous page. Next, the alternate exterior angles postulate says if two parallel lines are cut by a transversal, then the alternate exterior angles are congruent. And lastly, the consecutive interior angles postulate says if two parallel lines are cut by a transversal, then the consecutive interior angles are supplementary. These are all exactly the same ideas that we were talking about on the previous page, but we've just given the ideas a name. Let's move on to the next page. In this next diagram, what I'd like us to do is to find the measures of all of the angles here. We're given this one angle of 70 degrees, and we'd like to find the measure of all the other angles. Well, we know vertical angles are congruent, so angle 8 would have to be 70 degrees as well. We know that corresponding angles are also congruent. So angle 3 and 70 degrees would have to be the same. That would have to be 70. Angle 8 and angle 1 would also have to be 70 degrees. We could also say that 1 and 3 were the same because they're vertical angles. Let's see what else we have here. We know that angles 1 and 2 are a linear pair, so they would have to add up to 180 degrees. Since angle 1 is 70 degrees, angle 2 would have to be 110. Another way of looking at this, we could also look at angle 3 and angle 5. Those are consecutive interior angles, and consecutive interior angles are supplementary. So if angle 3 is 70, angle 5 would have to be 110, so they would add up to 180. Then we have vertical angles being congruent, so angle 7 would have to be 110 degrees. And then going up above, angle 4 would also have to be 110 degrees because consecutive angles are supplementary. Let's look at this next idea. This is the perpendicular transversal postulate. If a transversal is perpendicular, that should say is, change that to an S, is perpendicular to one of two parallel lines, then it is perpendicular to the other. So let's take a look at this idea. Let's say we've got two lines, and this is just a sketch, doing the best I can to make them parallel. So let's say we have these two lines that I'm going to tell you are parallel. So I will put the symbol for parallel on them. And now let's say that I have a transversal that's perpendicular to one of them. So I'm going to draw that transversal. And I'm going to name these lines L, M, and P. And I'm going to tell you that L is perpendicular to M. Well, if these lines are parallel, L is also going to have to be perpendicular to P. Because think about it, if these lines are parallel, let's call this angle 1 right here. And here we have angle 2. Angle 1 is going to have to be congruent to angle 2 because they're corresponding angles. And therefore, if angle 2 is 90 degrees, so must angle 1 be. So therefore, line L and line P will have to be perpendicular. So therefore, line L must also be perpendicular to line P. Now let's move on to our next page. We are given this diagram, and I'm going to label some points here, or some lines. I'm going to tell you that this is line M, K, and G, and I'm going to tell you that line K is parallel to line G. So we can actually put the symbols for parallel here. And we would like to know, based on the theorems and postulates that we've learned, which theorem or postulate justifies each of the following statements. So for instance, angle 1 is congruent to angle 6. Well, since K and G are parallel, and angle 1 and angle 6 are alternate exterior angles, we're going to say the alternate exterior angles postulate. You can see I'm abbreviating this, but that's fine. Alternate exterior angles postulate. Let's look at angle 4 and angle 5. What theorem or postulate justifies the angle 4 is congruent to angle 5? Well, those are alternate interior angles. So we're going to say the alternate interior angles postulate. Angles 2 and angle 3, if we add them together, equals 180 degrees. Well, angles 2 and 3 form a linear pair. So we're going to say that is the linear pair postulate. That's going back a little bit in our lessons. Angle 2 is congruent to angle 5. Angle 2 and 5 are corresponding angles. So we're going to say the corresponding angles postulate. Angle 4 plus angle 8 equals 180 degrees. Well, angles 4 and 8 are consecutive interior angles. So we're going to say the consecutive interior angles postulate. And lastly, we want to know how we can justify that angle 1 is congruent to angle 3. Well, those are vertical angles. That's why they're congruent. So we're going to say that is the vertical angles theorem. Let's move on to the next page. We're given this diagram, and we're asked to solve for x. Well, this angle of 110 degrees and 2x plus 10 degrees, where they're marked, those are alternate exterior angles. I do want to give you some information on this before we begin. Let's call this lines L and M and transversal T. I'm going to tell you that line L is parallel to M. That's essential information before we do anything else. So we have two parallel lines cut by a transversal. And when two parallel lines are cut by a transversal, the alternate exterior angles are congruent. So we could say that 110 degrees is equal to 2x plus 10 degrees. And that gives us an equation to solve. So we'll subtract 10 from each side, and we end up with 100 equals 2x. We want to get x alone, so we'll divide each side by 2, and x gives us 50 degrees. That is it for today. We'll see you next time.